So welcome to this video all about solving quadratics. Remember, you can find this PDF on MathsUpgrade.co.uk along with all the clues and the solutions. Now there's 4 ways to solve a quadratic. You can either use a quadratic formula, you can factorize, you can complete the square, or you can solve it graphically. This video is all about the first 3 methods. If you want to solve graphically, that's covered in a separate video file. First question. So to solve this equation here, giving our answer in the form a plus or minus root b, where a and b are integers, and that's 3 marks. Now the fact it's given in this form here suggests it cannot be factorized. So we're going to use the quadratic formula. First of all, we're going to find the coefficients of x squared, of x, and this term by itself, and then write them quite clearly above the formula here, ax squared plus bx plus c equals 0. Then by inspection we can see the value of a is positive 1, the value of b is negative 6, the value of c is negative 8. Substituting those into the quadratic formula here gives you this expression here. Be careful to square the negative 6 here. Following it through, don't evaluate it as a decimal since you need it as a square root, as a surd, and an answer would be 3 plus or minus root 17. And that is your final answer for 3 marks. Question 2 asks us to solve this inequality. X squared is greater than 3x plus 4. So the first thing we're going to do is get it in the form of a quadratic. So we're going to subtract 3x plus 4 from both sides. That gives us x squared minus 3x minus 4, which is greater than 0. Now I can actually factorize this. So to factorize this, you need to look for 2 factors which multiply to give negative 4 and add to give negative 3. Those 2 factors are negative 4 and 1. So this is the form factorized here. What I'm now going to do is going to put each of these brackets equal to 0. So x minus 4 is equal to 0. So that means x equals 4 by adding 4 to both sides. And x plus 1 equals 0. That means if I subtract 1 from both sides, I'll get x equal to negative 1. So here's your solution here. Now how do I know which way these inequality symbols are supposed to go? Well, quite simply, just choose a value of x. So let me choose the value of x as being 5. So I'm going to make sure that when I choose that value of x, that this side has got to be greater than that side. So for a value of 5, for example, 5 squared is 25, and 25 is greater than 3x plus 4, because 3x plus 4 would be 19. 3 times 5 plus 4 is 19. So 25 is greater than 19. So my value of x has got to be greater, definitely greater than 4, since 5 works. I can try it for 3. Okay, so 3 squared is 9 greater than 3 times 3 plus 4, and it's not. So my value here is definitely going to be greater than 4. And you can do a similar method for this one here. So the whole question there is worth 3 marks. Question 3 asks us to solve this inequality, x squared greater than 3 brackets x plus 6. So the first thing I'm going to do is I'm going to subtract 3 brackets x plus 6 from both sides. That gives me x squared minus 3 x plus 6. Then I'm just going to expand the bracket there to get it in the form of a quadratic. That gives me x squared minus 3x minus 18. I can factorize this. I need to look for 2 factors of negative 18 which add to give negative 3. And those are 3 and negative 6. So that's it factorized there. Now I need to put each of these brackets equal to 0. So when x minus 6 equals 0, if I add 6 to both sides, I'll get x equals 6. And when x plus 3 equals 0, when I subtract 3 from both sides, I'll get x equals negative 3. Now which way around do these symbols go? Similarly with the last question, I'm going to show you again for example for this one. So let me try a value of x which is less than 6. Let me try a value of 5. So 5 squared into this equation here. 5 squared is 25. 5 plus 6 is 11. 3 times 11 is 33. So 25 is not greater than 33. So a value of less than 6 has not worked. So let's try a value of greater than 6. Let's try 7. 7 squared is 49. Is 49 greater than 3 times 7 plus 6? 7 plus 6 is 13. 3 times 13 is 39. So 49 is definitely greater than 39. So this symbol must go that way around. And you can do similarly for this value here as well. So that question there was 4 marks. In question 4, I need to solve these simultaneous equations, and this involves quadratics as well. If you're not sure on how to solve simultaneous equations, be sure to check out my video file on this channel for further help. So what I'm going to do here is I'm going to rearrange this bottom equation so that y is the subject of that equation. In other words, I'm going to add 3x to both sides. That gives me y equals 3x plus 13. Now, into the top equation here, which I've labelled A, I'm going to substitute this equation here. That gives me x squared plus y squared, which is now 3x plus 13 all squared, so I'm putting in brackets, equals 25. When I expand the brackets, I'll get this expression here, x squared plus 9x squared plus 78x plus 169 equals 25. Remember, when I'm expanding these brackets, it's a double set of brackets here, so I've just skipped a step here. The next thing I'm going to do is I'm going to simplify, so I'm going to collect like terms on this side. X squared plus 9x squared is 10x squared plus 78x plus 169 equals 25. I'm now going to get it in the form of a quadratic by subtracting 25 from both sides to make it equal to 0. So that gives me this here. Now I've noticed here each number here in the whole equation, each term here has got a factor of 2. Right, since this is an even number, that's an even number, that's an even number, and that's an even number. So I can divide everything by 2 here just to make the numbers smaller. That gives me 5x squared plus 39x plus 72 equals 0. I can factorize this. To factorize this, I get this. 5x plus 24 x plus 3 equals 0. What I do now is I just put each of these brackets equal to 0. So 5x plus 24 equals 0. Subtract 24 from both sides. That gives me 5x equals negative 24. Then divide both sides by 5. Gives me x equals negative 4.8. Similarly with the other bracket, x plus 3 equals 0. Subtract 3 from both sides. Gives me x equals negative 3. So I found there two values of x. What I need to do now to finish off this question is substitute each value of x into one of these equations here. The easiest equation here is the bottom one. So substitute each of these values in turn into this bottom equation to get the corresponding values of y. And that's what I've done here. So the answers are y equals negative 1.4 and y equals 4. I'm just going to pair those up with the corresponding values of x when I write on the answer line. So x equals negative 4.8 goes with y equals negative 1.4, so this side here, and x equals negative 3 goes with y equals 4. And the whole question there is worth 5 marks. Question 5 is very similar to question 4, which we just looked at. I need to solve these algebraically. Since there's two equations and two different unknowns, I need to use simultaneous equations. Again, if you're not sure on how to use simultaneous equations, be sure to check out my video file on this channel. So what I'm going to do here, I'm going to rearrange this so that x is the subject of the equation. I can do that by just adding 2y to both sides. That gives me x equals 2y minus 3. When I sub that into the top equation here, I'll get x squared, which is 2y minus 3, 2y minus 3, plus y squared equals 18. I expand this line, that gives me 4y squared minus 12y plus 9 plus this y squared here equals 18. I'll simplify on this side. 4y squared plus y squared is 5y squared minus 12y plus 9 equals 18. Then you can see this is looking like a quadratic. Let's just make it equal to 0 by subtracting 18 from both sides. That gives me this line here. Now factorizing, that gives me 5y plus 3, y minus 3 equals 0. Make each bracket equal to 0. So here 5y plus 3 equals 0. So we get y equals negative 3/5, or you can write it as a decimal. And I get y minus 3 equals 0, so y equals 3. I'll substitute each of these values of y into one of these two equations to get the corresponding values of x. The bottom equation is much easier, so I'm going to substitute them into the bottom equation here. So x minus 2y equals negative 3, so that gives x minus 2 times negative 3/5 equals negative 3. If I then evaluate this bracket here, 2 times negative 3/5 is actually negative 6/5, but since I'm subtracting, x subtract negative 6/5 is the same as x add 6/5, and I've written it as a decimal here, x add 1.2. that equals negative 3, and then just subtract 1.2 from both sides. For this one, y was 3, so x minus 2 times 3 equals negative 3. That gives x minus 6 equals negative 3, so x equals positive 3. Then I'll just pair up those corresponding values. Remember, x as being negative 4.2 corresponding to this value of y, and x as being 3 corresponding to this value of y. The whole question there was worth 5 marks. Question 6 gives me a right angle triangle in the diagram. Now, as soon as you see a right angle triangle, you usually just think Pythagoras or trigonometry. But this question here gives us the area of the triangle as a value. So this question actually is just involving probably just a formula for the area of a triangle. So we need to find essentially an expression for the area of this triangle, make it equal to this number here, and then find the value of x by solving the quadratic. When I find the value of x, I can then find the length of the shortest side, which must be this side since I'm subtracting 2 from x. So let's go and do that now. So here's the important information in the question. The area is 27.5. Here's the formula for the area of a triangle, half the base times the height. So the base and the height are just these two sides. So when I multiply them together and divide by 2, that equals 27.5. What I'm going to do here, I'm just going to neaten this up a bit. I'm going to get rid of this denominator by multiplying by 2 on this side. So I need to multiply by 2 on this side. That gives me 55 equals x minus 2, x plus 4. All I'm going to do now is expand the brackets and then form the quadratic by subtracting 55 from both sides to make the equation equal 0. I can factorize this since 9 and negative 7 are both factors of negative 63, which add to give 2. So since they equal 0, both these brackets must equal 0. So 0 equals x plus 9. That means x equals negative 9. And 0 equals x minus 7. That means x equals 7. Now this cannot be a solution since if x is negative 9, that means that this and this actually would both be negative length. There's no such thing as a negative length. So this isn't a plausible solution, so you can ignore that solution. This one here gives x equals 7, so that's our solution. That's not the final answer though, that's just the solution to that quadratic, x equals 7. Now all I need to do, substitute x equals 7 into these sides and see which is the shorter side. So x equals 7, 7 minus 2 gives 5, and 7 plus 4 gives 11. So this is the shorter side, and so the length of the shortest side is 5, and remember it's in centimetres, so all the measurements are in centimetres. And that question there was worth 4 marks. In question 7, I'm given two inequalities. 3n plus 2 is less than or equal to 14, and 6n all over n squared plus 5 is greater than 1. I need to find all the possible values of n. Remember, n is a whole number. So what I'm going to do, I'm going to solve this equation here, since that's really straightforward. It's just a linear equation. Okay, so to solve that, what I'm going to do, I'm just going to subtract 2 from both sides, which gives me 12 on this side, and then divide by 3. That gives me n is less than or equal to 4. What this says is that n, the number, is less than or equal to 4. So it could be 4, 3, 2, 1, 0, negative 1, negative 2, etc. Okay, the next thing I'm going to do is I'm going to solve this equation here, equation b. So first thing I'm going to do, I'm going to multiply both sides by the denominator here. So that's going to be 6n is greater than n squared plus 5. Then I'm going to form the quadratic by subtracting 6n from both sides. That gives me 0 is greater than n squared minus 6n plus 5. What I'm going to do now, I'm going to factorize this, since negative 1 and negative 5 are factors of 5 which add to give negative 6. So I'm going to put each of these brackets equal to 0. That means that if 0 equals n minus 5, n has got to be less than 5, and if 0 is greater than n minus 1, n has got to be, well, 1 has got to be less than n, so n has got to be greater than 1. So what this says is, the first solution here tells us that integer has got to be less than or equal to 4, and this tells us the integer has got to be in between 1 and 5, not including 1 and 5. So this tells us it could be 2, 3, than 4, and this tells us it could be less than or equal to 4. So here's the whole numbers, the integers which meet both of these conditions. Okay, so that's 5 marks for that question. In question 8, I'm given a rectangle and a right angle triangle, and I'm told that the area of the left hand shape is greater than the area of that shape there. You need to find the set of possible values of x. The area of a rectangle is given by the length times by the width, and the area of the triangle is given by base times height divided by 2. And I know that the length times the width is greater than the base times height divided by 2. So if I substitute the expressions for the length and width of the rectangle in, and the height and base of the triangle, I get this inequality here. What I'm going to do, I'm just going to neaten this up. So I'm going to expand the brackets on the left hand side, which gives me this. I'm going to just cancel the factor of 2 on the numerator and denominator on this side of the inequality here. So that leaves me with just x times x, which is x squared. Now I'm just going to subtract x squared from both sides, which leaves me 2x squared minus 5x plus 2 is greater than 0. So here's my quadratic now. Now what I'm going to do is I'm going to factorize this expression here, which gives me 2x minus 1, x minus 2, which is greater than 0. So I'm going to put this bracket as being equal to 0. That gives me 2x minus 1 equals 0. So if I add 1 to both sides, I'll get 2x equals 1. Divide by 2, x equals a half. So x equals a half is one solution. And the other solution, x minus 2, if that equals 0, x equals 2. Now, if I get x equals a half, and I try and substitute that into these diagrams here, x equals a half, well, if I do a half subtract 1, that gives me a negative length. And I cannot have a negative length, it's impossible. So this cannot be a solution to our diagram. This is the only solution, and so we know that x must be greater than 2. X must be greater than 2, since when I substitute it into here, you can see that x must be greater than 2. That question there was 5 marks. Question 9. The region R is shown shaded in the diagram, and it's between those two circles. Those circles are called concentric circles since they've got a common centre. The outer circle's got a radius of 2n plus 6, inner circle's got a radius of n minus 1. The area of that shaded part is greater than the area of a circle of radius n plus 13. So imagine a separate circle with a radius of n plus 13. That would have a smaller area than the area shaded here. N is a whole number. Find the lowest possible value of n, showing already working. So this question here is worth 5 marks. So what I'm going to do here is going to first of all find the area of a circle of radius n plus 13. Since the area of a circle is given by pi r squared, then that gives us pi, and then r squared is n plus 13. So when I expand that, I'll get pi brackets n squared plus 26n plus 169. So there's the area of a circle radius n plus 13. Now I need to recognise that the shaded area here is the area of the outermost circle with this radius. Subtract the area of this white circle in the middle with that radius there. So if I can find those areas, and if I can subtract them, I'll get the shaded area. I can then relate that to this area of this circle which I found in blue. Let's find the area of the outer circle. Remember, area is given by pi r squared, so pi times the radius squared there would give me pi times 2n plus 6 all squared. Expand the brackets and you get this. So that's the area of the outer circle. The area of the inner circle, again, is pi r squared. Here's the radius. Expand it and you get this expression here. So the shaded area is these two expressions subtracted. Let me do that here. And if I simplify, well, 4n squared take out n squared is 3n squared. 24 subtract negative 2n gives me 26n, since I'm subtracting a negative. 36 subtract 1 gives me 35. So now here's my shaded area. Now the question tells us the shaded area must be greater than this area I've calculated here. So I've written inequality here relating those two. Now what I can do is I can just cancel by a factor of pi on both sides, and then collect like terms by subtracting n squared plus 26n, and then subtracting 35 from both sides. That gives me 2n squared, which is greater than 134. If I divide both sides by 2, I'll get n squared, which is greater than 67. Then if I just square root, well, I haven't got a calculator available for this question, but I know that the square root of 67 is going to be slightly greater than 8. So the smallest possible positive integer is therefore going to be 8. Right? So therefore n has got to be greater than 8, which is 9. So that question there was 5 marks for the whole question. If you're not sure on what I did with areas of circles, be sure to check out my clip on this channel on that topic. In question 10, we're given a lot of information. We're told that the length of a rectangle is the same as the length of each side of a square. The length of the rectangle is 4 centimeters more than 3 times the width of the rectangle, and the area of the square is 66 centimeters squared more than the area of the rectangle. We need to find the length and width of the rectangle, showing all our working. So there's 3 facts here essentially. The first fact relates the length of the rectangle to the length of the square. The second fact relates the length of the rectangle to the width of the rectangle. And the third fact relates the area of the rectangle to the area of the square. So here's the 3 facts. And here they're represented using diagrams and equations. So the first one, the length of the rectangle, so the long side of a rectangle, is same as the side of a square. And all the sides of a square are equal. So I'll put these little marks on and on here as well, because they're equal, right? The second fact, the length of the rectangle is 4 centimeters more than the width of the rectangle. So imagine the width of the rectangle is w, so imagine this is w here. The length of the rectangle is 4 centimeters more than 3 times the width. So here's 3 times the width, 3w, plus 4 centimeters more than that. And since from fact 1, the length of the rectangle is same as the side of the square, this square now we know must be 3w plus 4 in width and in length. The third fact is this one. The area of the square is 66 centimeters more than the area of the rectangle. So the area of a square is equal to the area of the rectangle plus 66. In other words, the area of the square is greater than the area of the rectangle by 66. So there's the 3 facts. Okay. Now what we're going to do is we're going to use those facts. Okay. We're going to use this fact 3 and fact 2 combined. Okay. Since we've already used fact 1 when we came to fact 2. So fact 3 says the area of a square. The square is side 3w plus 4, so the area is going to be 3w plus 4 squared, is equal to the area of the rectangle. The area of the rectangle is length times width, so w times 3w plus 4 plus 66. So if I expand the left hand side of this equation, expand the double brackets, I'll get this expression here. And then if I expand this single bracket, I get this expression here, plus 66. And now you can see that a quadratic is forming. So let's just collect all the like terms onto one side by subtracting 3w squared minus 4w minus 66. And that gives me this equation here. Now I can see that each expression here, each term on this side of the equation has got a factor of 2. Right, and the 0 has also got a factor of 2. In other words, I can divide everything by 2. So that gives 3w squared plus 10w minus 25 equals 0. That just makes the numbers smaller and easier to use. Now I can factorize this by doing this. And now since that equals 0, I can put each bracket as equal to 0. So 3w minus 5 equals 0. That means that the width must be 5/3. And w plus 5 equals 0. That means that w equals negative 5. Now remember, w is what is the letter I use for the width, right? So I can't really have a negative width. That doesn't make sense, right? So this isn't a plausible solution for our problem. So this is the solution here. Width is 5/3. Now we need to find, in the question, you need to find the length and the width. So I found the width of the rectangle. Now to find the length the length is just 3 times the width plus 4. It tells you that in fact too. Right, so if I times this width by 3 and add 4, I'll get 3 times 5/3, which is 5, add 4, which is 9. So there's my answer there. Length is 9, width is 5/3, and they're both in centimetres, and that would be 6 marks for that question. That was the hardest question on the non-calculator section of this booklet. The remainder of the questions in this video and in the booklet are all calculator questions, and you'll find a lot of them you need the quadratic formula to solve them. Question 11 states that we need to solve x squared minus 5x plus 3 equals 0. So to solve this, we're just going to use the quadratic formula. Since I cannot factorize this, there aren't two factors of 3 which add to give negative 5. So I'm going to put it in the form ax squared plus bx plus c, and then by inspection I'm going to see what a, b and c equal. So you can see that a equals 1, b equals negative 5 and c equals 3. If I then substitute those into the quadratic formula, I get this here. Evaluating all this inside the square root gives me root 13. So my solutions are going to be 5 plus root 13 over 2 and 5 minus root 13 over 2. When I round those to 3 significant figures, I'll get 0.697 and 4.30. Those are both 3 significant figures for 3 marks. A big clue here that you can't factorize it is also the fact that the solutions need to be correct to 3 significant figures. Question 12 is another fluency question on solving a quadratic for 3 marks. Now this one doesn't say to round your answer, so this to me suggests you can probably factorize this, but we'll see. So you can factorize it since the factors of negative 24, which add to 5, are 8 and negative 3. So then here's the factorized form. Since both these brackets multiply to give 0, I can put each bracket as equaling 0. So x plus 8 equals 0, so x must be negative 8, and x minus 3 equals 0, so x must be positive 3. So there's my solutions there. X equals negative 8, and x equals 3. That's 3. Question 13. Solve x minus 2 all squared equals 3. Give your solutions correct to 3 significant figures. So the fact that we need to round our numbers suggests to me that you can't factorize it. It's only 2 marks. First thing we're going to do is expand this bracket here. So that gives me x squared minus 4x plus 4 equals 3. Then I'm going to subtract 3 from both sides, and then by inspection I'm going to look at what a, b and c equal. The coefficients of x squared, x and this number by itself. I'll then substitute those into the quadratic formula. So you can see that a equals 1, b equals negative 4 and c equals 1. When I substitute them in, I'll get x equals 4 plus or minus root 12 over 2. If I then evaluate this, I'll get x equals 0.2679 and x equals 3.732. So when I round that, I'll get x equals 0.268 and x equals 3.73 to 3 significant figures. In this question here for 3 marks, I need to solve this expression. Slightly more difficult since I'm given a fraction on the right hand side and it's an inequality. So the first thing I'm going to do, I'm going to expand the brackets here. So that gives me 1 minus 2x plus x squared. Then I'm just going to subtract 9 over 25 from both sides, which gives me this. And then by inspection I can see that a equals 1, b equals negative 2 and c equals 16 over 25. So substituting them into the quadratic formula, I'll get this expression here. When I evaluate this, I'll get x equals 2 plus or minus root 1.44 over 2. And you maybe recognize that 1.44, you can easily square root this. Since the root of 144 is 12, the square root of 1.44 is going to be 1.2. When I evaluate x, I'll get x equals 0.4 and x equals 1.6. So my answer is that x is in between 0.4 and 1.6, and that would be 3 marks. Question 15, I need to solve 2x squared plus 3x minus 2, which is greater than 0. So what I'm going to do, I'm going to attempt to factorize this, and I can factorize it since I can get 2x minus 1 and x plus 2 are both greater than 0. So then I've got two brackets which both multiply to give greater than 0. So if I put each one as equal to 0, I'll get x equals 0.5 and x equals -2. So my solutions are x is less than -2 and x is greater than 1/2, and that is 3 marks. Question 16 for 3 marks, very similar to question 15. We need to solve this inequality here. It's already in the form of a quadratic, so I'm just going to factorise it, and that will give me 2x plus 3 and x minus 4 is greater than 0. So this bracket, I'll put it equal to 0. That gives me x equals -1.5, and this bracket would give me x equals 4. So again, look at the shape of this curve. This is a positive x squared curve, so it's a u curve. So at what point would that line of that curve be greater than 0? Be greater than 0 at when x is less than -1.5 and when x is greater than 4. Otherwise it would be less than 0. So that was 3 marks for that question. Question 17 suggests that I need to give my solutions to 3 significant figures, and that suggests that I need to use the formula, the quadratic formula. So it's already in the form of a quadratic, so I'm just going to put this underneath it, and then by inspection look at what a, b and c equal. So you can see that a equals 5, b is -4 and c is -3. Substitute those into the formula and this is what you get. So x must equal 4 plus or minus root 76 all over 10. When I evaluate both forms of that, I'll get x equals -0.47178 and x equals 1.27178. To 3 significant figures. Here's my answers here for 3 marks. Question 18. To solve algebraically these 2 equations simultaneously. This question is worth 5 marks. So what I'm going to do, I'm just going to rearrange this bottom equation here and then substitute it into the top equation. So if I rearrange this bottom equation so that x is the subject of that equation there, I subtract 4y from both sides and divide by 3, so x would equal 7 minus 4y all divided by 3. If I then substitute that into the top equation here, I'll get this expression here. Remember to put x in brackets, so it would be 7 minus 4y divided by 3 all in brackets squared minus 4y squared. If I then just expand those brackets, remember I've got the denominator as 9 here still, and then I need to multiply everything by 9 to get rid of this denominator. So that makes this as 36y squared and this is 81. Then I'm just going to simplify and rearrange. Since on this side I've got essentially a -y squared, I'm just going to move everything to the right hand side. That gives me 20y squared plus 56y plus 32. You can see here I've got all the terms here are factors of 2 since they're all even numbers. So I'm just going to divide everything by 4. So that gives me 5y squared plus 14y plus 8. I can factorize this expression here to give this, then each bracket I can put it equal to 0, so that would give me y equals -4/5 and y equals -2. I just need to finish this off now by substituting each corresponding value of y to get the corresponding value of x. I'm going to substitute them into this equation here, since I've already rearranged equation b to give this, and this has got x as the subject of the equation. So x must equal 7 minus 4y all divided by 3. So 7 minus 4 lots of -4/5 all divided by 3. With the calculator, it just gives me x equals 3.4. And similarly, when I substitute y equals -2 into this equation, I'll get x equals 5. So there's my 2 pairs of values there for 5 marks. Question 19 is very similar to question 6. It's slightly more difficult and it is worth 6 marks. So I'm told I've got a right angle triangle here. So straight away, when you're given a right angle triangle, remember trigonometry or Pythagoras is usually what it's associated with. It tells me here that the measurements are in centimetres and the area of the triangle is 2.5 centimetres squared. Find the perimeter of the triangle. Give your answer to 3 significant figures. You must show while you're working. So the fact that I mentioned Pythagoras, it does involve Pythagoras, but I don't need it until later on. What I need to do first of all is use this fact here, that the area of the triangle is 2.5 centimeters squared. Then I can form an equation relating these, and then I can find the value of x by solving the quadratic. When I found the value of x, I can substitute it in, and then I can use Pythagoras to find the longest side, and therefore the perimeter of the triangle. So let's do that now. So here's the formula for the area of the triangle. Base times height divided by 2. So the area is 2.5. So 2.5 must be equal to x times x minus 2, all divided by 2. So that's base times height divided by 2. I'm just going to neaten this up now. I'm just going to multiply both sides by 2. So that gives me 5 equals x brackets x minus 2. Expand the brackets and then subtract 5 from both sides. And that's what I get. So now I need to solve this quadratic here. So when I'm solving this quadratic, I'm going to try and factorize it, but I cannot. So I'm just going to use the quadratic formula. So by inspection, you can see that a equals positive 1, b equals negative 2, and c equals negative 5. Substitute those in, and I get x equals 2 plus or minus root 24, all divided by 2. I get corresponding values of x as being negative 1.449 and x as being 3.449. Let us consider this negative value of x. X is also the base of this triangle. So can I have a negative base? I cannot have a negative length, so that doesn't make sense. So this is my only plausible solution. What I'm going to do now is going to substitute this value of x into the base and the height on this diagram. That gives me this here, 3.449 and 1.449. Now I need to find the perimeter of the triangle. To find the perimeter, I need that third side, the longest side. So to find the hypotenuse, remember with Pythagoras, you need to square the short sides, add, and then square root. If you're not sure on how to do that, be sure to check out my video file on this channel. That gives me 3.741. So finally the perimeter is x, add x minus 2, add 3.741, which is 8.64 to 3 significant figures, and that is your 6 marks for that question. This 5 marker involves trigonometry, and you can tell that just from the question and the fact that it involves right angle triangles. So I need to find the value of x given that the tan of e equals the tan of f. So let's think about what tan means, and if you're not sure on trigonometry, be sure to check out my video file on this channel. The tan of an angle is equal to the opposite side divided by the adjacent. So I can see that the tan of E is the same as x, which is the opposite, divided by the adjacent, which is 4x minus 1. And also for this triangle, the tan of f is going to be 6x plus 5 divided by 12x plus 31. Since this purple equation here must equal this purple equation, this brown equation here, I can equate them. And now I'm just going to cross multiply. I'm going to cross multiply, since that would get rid of the denominators on both sides. So I'm going to do x times 12x plus 31 and 6x plus 5 times 4x minus 1. Remember, I need to put these in brackets here on both sides since I'm multiplying more than one term. So you can see it's starting to look like a quadratic. I just need to expand the brackets now. So when I'm expanding the brackets, I'll get this. I can see there's more x squared on the right hand side, so I'm just going to subtract both of these terms from both sides to give me 12x squared minus 17x minus 5, which equals 0. I can factorize this, and that's what I'm going to do here. And then I get corresponding values of x as being negative 1/4 and 5/3. So again, x as being negative value. Can I have a negative value of x? Well, clearly I can't, because that would mean that this side here would be negative. And actually lots of the sides would be negative. So I can have a negative length. So that's not a plausible solution. So this is my solution here. X is 5/3. And that is all I need to work out. That question there was worth 5 marks. Question 21 is a 6 marker. A solid cuboid has got a volume of 40. It's got a total surface area of 100. And one edge of the cuboid has got a length of 2 centimeters. Find the length of a diagonal of the cuboid. Give your answer correct to 3 significant figures. let's just check that these are all corresponding units, so they're all in centimeters cubed or centimeters squared or centimeters, so that's fine. This question will involve 3D Pythagoras. If you're not sure on 3D Pythagoras, be sure to check out my video file on this site. So first of all, I'm going to relate the volume with the length, width and height. I'm told the volume is 40, and I know the volume of a cuboid is just the length times the width times the height. So that's going to be 2 times the width, which I'm giving a letter of W, and a length, which I'm giving a letter of L. If I make L the subject of this equation, I'll get L equals 20 over W. The next thing I'm going to do is I'm going to find the surface area and relate that to the length, width and height. I'm told the surface area of the cuboid is 100. And I know the surface area of a cuboid is given by the area of the 3 visible faces, the 3 visible rectangles, multiplied by 2. When I expand this expression, I'll get 100 equals 4W plus 4L plus 2LW. If I substitute this expression here for L, I'll get 100 equals 4W plus 4 brackets 20 over W plus 2W brackets 20 over W. I just need to expand this now. If I expand this and then divide by 4, I'll get 25 equals W plus 20 over W plus 10. I just need to neaten this all up now. I'm going to make it equal to 0 by subtracting 25 from both sides. I'm also going to multiply by W, since I can see that I can do that to get a proper quadratic. If I multiply by W, I'll get W squared plus 20 minus 15W. I'm going to rearrange so it's in the form of a quadratic, and that gives me 0 equals W squared minus 15W plus 20. By inspection, you can see the values of A, B and C. I'm going to substitute them into the formula. That gives me 2 values for W, 1.479 and 13.52. I'm just going to check if these are both valid solutions. If I get a negative length or anything similar, then I know that they're not valid. I'm just going to put them into this expression here for the length. That would give me, actually, for this value, it would give me the length of 13.52, and for this value it would give me the length of 1.479. So these are definitely correct. I'm now going to use 3D Pythagoras. 3D Pythagoras states that the length of the diagonal of 2 opposite corners, 2 opposite vertices, is the square root of the square of each of the edge lengths on that cuboid. Again, if you're not sure on how I've done that, be sure to check out the video on this site. When I round, I'll get 13.7 centimeters, and that is my 6 marks for that question. You can see the questions are getting more and more difficult now. Question 22 involves the area of a non-right-angled triangle using trigonometry. I'm told the area of this triangle is 6 root 2. Give the value of x to 3 significant figures. So the formula I need here is the area of a triangle is given by half AB sine C. So the half of the product of 2 sides multiplied by the sin of the angle between them. So here's my 2 sides and here's my angle between them. So I need to find the value of x. I'm just going to use this formula here. I'm going to substitute in everything that I know. So the area is 6 root 2. AB is 2x minus 1. BC is x plus 3. And angle B is 45 degrees. If I then evaluate sin 45, I'll get root 2 over 2. And then I'm just going to simplify. And that would give me 6 equals a quarter, 2x minus 1, x plus 3. All I've done here, I've just taken into account the fact that I'm halving everything here, so that'll be a quarter. The next step here, I'm just going to get rid of this quarter by multiplying everything by 4 on both sides. And then I'm going to expand these brackets. That will give me 24 equals 2x squared plus 5x minus 3. If I subtract 24 from both sides, I'll get 0 equals 2x squared plus 5x minus 27. Look by inspection, A equals 2, B equals 5, c equals negative 27. Now, when I substitute them into the quadratic formula, I'll get x equals negative 5 plus or minus 241 over 4. Evaluating that with a calculator, I'll get x equals negative 5.1, which cannot be possible since lengths would be negative. So if x is negative, then that there would be negative, and that would be negative. So the other value, x equals 2.631. So I found x. All I need to do now is just round it to 3 significant figures, and that would be 2.63, and that would be 5 marks for that question. Question 23 is a 7 marker. We don't get many 7 markers in maths, so this is a really big question. This involves probability and solving quadratics. It's actually split up into 2 parts, parts A and B. It tells us that there's y black socks and 5 white socks in a drawer. Josh takes at random 2 socks from the drawer. The probability he takes 1 white sock and 1 black sock is 6 over 11. We need to show that 3y squared subtract 28y plus 60 equals 0. So in essence, you need to be really good at probability. If you're not good at probability, especially with conditional probability, then you need to be looking at my video on this channel. So there's y black socks and 5 white socks. He's going to take 2 socks. The probability of taking white and black in any order, which is what this is, 1 white and 1 black sock in any order, is the probability of white then black, or the probability of black then white. And you've got to add these together since it's an OR question. We know the probability is 6 over 11. So here's this side of the equation. The probability of white and black is, here's the probability of white. It's the number of white socks, which is given here, divided by the total number of socks. And here's the probability of then getting black after the white. The black sock, the number of black socks won't have changed, so that'll be y. The number of total socks will now be 1 less than what it was before. So in essence, this is what we're doing for the probability of white then black. And similarly, here's the probability of black then white. You can just see the white and blacks here are just swapped over. So let's substitute in what we know. We know there's 5 white socks, and we know the total is y plus 5. So that's this fraction here. Multiply by the number of black socks divided by the total, but subtract 1 because you've taken out 1 white sock here. This product here is very similar. You can work that out for yourself. Next, all I'm doing now is I'm basically just going to collect like terms and find the products of these. When I multiply these 2 fractions together, I just get 5y in the numerator, and when I multiply 5 plus y times 5 plus y minus 1, that's the same as 4 plus y. So when I multiply 5 plus y by 4 plus y, I get this expression on the denominator here. Similar for this bracket here. Now I need to add, and I can add since the denominators are the same, so I can just add the numerators. What I'm going to do here now, just doing it on this side since I've run out of space, I'm just going to cross multiply. So I'm going to multiply the numerator here by 11 and the numerator here by the denominator here. Then when I collect like terms and I just divide by a factor of 2, since everything here is an even number, I get 3y squared minus 28y plus 60 equals 0, which is what I had to show in the question. So that there was worth 4 marks for that question. In part B, I need to find the probability that Josh takes 2 black socks, and this is for 3 marks. So essentially I need to find the value of y, since y is a number of black socks. So remember in the question we were given the fact that 3y squared minus 28y plus 60 equals 0. So essentially we just solve that quadratic. So let's go ahead and solve that quadratic now. By inspection I can see that a equals 3, b equals negative 28 and c equals 60. So if I substitute those into the quadratic formula, I'll get y equals 3.3 recurring and y equals 6. Now I cannot have 3.3 black socks, so that's not a solution for our problem. So this must be the solution, y equals 6. So there must be 6 black socks. so y equals 6. Now the probability of taking 2 black socks is the probability of black and the probability of black again. So it's black, it's probability of getting black times the probability of black again. Since there's 6 black socks and there's 5 white socks, probability of getting black must be 6 out of 6 plus 5, so 6 out of 11. And the probability of getting another black sock, well, there's now only 5 black socks left out of 10. So 6/11 times 5/10, which gives us 3/11 when I simplify it. And that question there was 3 marks. The whole question there was worth 7 marks. Question 24 is a 6-mark question. I'm given a parallelogram. I'm given the length of the two sides as being 10 minus x and 2x minus 1. And I'm given the angle between them is 150 degrees. The area of the parallelogram is greater than 15 centimeters squared. Show that 2x squared minus 21x plus 40 is less than 0. So first of all, let's remind ourselves about how to find the area of a parallelogram. Here's the formula here. The area of a parallelogram is the base times the perpendicular height. So if I just draw on the perpendicular height here, then you can see that since it's perpendicular to the base, it must be perpendicular to the top of the shape. That must be 90 degrees there. This must be 90 degrees here. So in essence, I formed a 90-degree triangle. Since I formed a right angle triangle, I can use trigonometry here. This angle is 90, so this must be 60 because it's subtracted from 150. So I've got a right angle triangle with 60 degrees. I know this side is 10 minus x. I need to find the height. If I can get the height here, then I can use this formula to relate it to the area. So from the point of view of this angle, using trigonometry, point of view of this angle, okay, so this side is the hypotenuse. I need the hypotenuse, and I need the side next to me, the adjacent. So adjacent and hypotenuse are related using the cos. So cos equals adjacent divided by hypotenuse. The height is the adjacent, so I'm just going to rearrange this so that adjacent is the subject of this equation. So adjacent equals cos times hyp. Adjacent is height, cos is cos of the angle 60, hypotenuse is 10 minus x. What I need to do now, I now need to just evaluate cos 60. Well, cos 60 is a half, so the height therefore must be 10 minus x halved. In other words, 10 minus x divided by 2. So I've got there the height in terms of x. What I'm going to do now, I'm now going to use the fact that the area of the parallelogram is greater than 15. So the area is greater than 15, and now the area of the parallelogram is given by the base times the perpendicular height. So the base is 2x minus 1, which is the same as this side here, because the opposite sides are equal. The height is 10 minus x all divided by 2. So that's my equation, that's my inequality here. Now to just simplify this, I'm just going to multiply by 2 on both sides. And if I multiply by 2 on both sides, I'll get rid of this denominator here. That gives me 2x minus 1, 10 minus x, greater than 30. If I expand the brackets, I get this. Simplify by subtracting 30 from both sides and collecting like terms. Then I get 2x squared minus 21x plus 40. Now I've just swapped the sides here. In other words, I've multiplied by negative 1 on both sides. So the inequality is now pointing this way. Okay, so that has shown that expression, that inequality there, I've shown it. And that is 3 marks there. The next part of the question is this. I'm asked to find the range of possible values of x for the final 3 marks. What I need to do now is I need to solve this inequality. So I'm going to solve it by factorising. When I factorise this, I get this expression here. Then, since the 2 brackets multiplied to give less than 0, I'm just going to put them equal to 0. I get x equals 2.5 and x equals 8. So, using these values, I know that the value of x, in other words, the value of x here, must be in between 2.5 and 8. And that is my 3 marks. Question 25. This question involves functions. In essence, I'm just substituting something into these quadratic. I need to find f of 5. In other words, x has been replaced by 5. Give my answer as a fraction for 2 marks. So if x equals 5, then this would be 1 over 5 plus 2 plus 1 over 5 minus 3, which is 1/7 plus a half, which is the same as 9 over 14, just with a calculator. That would be 2 marks. The second part of the question says write down the value of x for which the function is not defined. So can you think of a value of x for which you cannot define this? In other words, think of when x can make the denominator of either fraction equals 0. Because when you do divide by 0, you get an answer which is not defined. It's like infinity. So the values of x there would be -2, since -2 plus 2 is 0, or you can choose a value of 3, since 3 minus 3 is 0. So you've got a choice of answers there. Either x as being -2 or x as being 3. So that is your answer for part B. Now for part C. Given that f of x equals 4, find the possible values of x. Give your answer in that form, where p, q and r are positive whole numbers. And that final question there is 5 marks. So this is where the quadratic part comes in. Given that f of x equals 4, so in essence I need to equate this with 4. So I need to put it equal to 4. So 4 equals 1 over x plus 2 plus 1 over x minus 3. If I then just multiply both sides by x plus 2 and x minus 3, I get this expression here. Then I can just subtract from both sides x minus 3 and x minus 2, and I get 4x squared minus 6x minus 23 equals 0. Using the quadratic formula and following it through, I'll get x as being 6 plus or minus root 404 over 8, and then that'll give me a final answer when I simplify it by dividing by 2 on the top and bottom of x as being 3 plus or minus root 101 over 4. That's your final 5 marks, and that is the 8 mark question there of question 25. Question 26 is just a 2 mark question, but it does involve writing this in this form, and you can see this is completing the square. So I need to get a whole number for a and b. To complete the square, I need to write first of all this expression here in the form 1x squared plus bx equals c. So for this one, I've already got a coefficient of 1 for the x squared, so I need to add 7 to get this as x squared plus 6x equals 7. Now if I add b over 2 all squared to both sides, so b over 2 would be 3 to both sides, squaring it would be 9. I'd get x squared plus 6x plus 9 equals 16. You need to factorize this left hand side into a perfect square. In other words, one set of double brackets squared, one set of brackets squared. So that would be x plus 3 all squared, and that still equals 16. Now all I need to do is write it in the form required, and that is x plus 3 all squared minus 16. That is in the form required since a and b are both integers, and that is 2 marks for that question. Question 27 is very similar to question 26. I need to complete the square, as you can see from here. So first of all, I need to write it in the form 1x squared plus bx equals c. So I need to expand the brackets here. That gives me x squared minus 4x minus 32. And then if I bring 32 to this side, I'll get x squared minus 4x equals 32. If I then add b over 2 squared to both sides, so I need to add negative 4 over 2 squared to both sides, that gives me x squared minus 4x plus 4 equals 36. Factorize the left hand side into a perfect square. In other words, a set of brackets squared, which is x minus 2 all squared, that equals 36. and then just write it in the form that's stated in the question. So the answer there would be a equals 2 and b equals negative 36. That question there was worth 3 marks. If you struggled with any of the questions in this booklet, be sure to check out the other booklets on MathsUpgrade.co.uk, in particular simultaneous equations and also trigonometry and 3D trigonometry. Thanks for watching.